Okay, we're back. Classic grade 10 problem here. A 5-meter long ladder rests on a wall that is 2.5 meters away from the base of the ladder. What is the angle formed between the ladder and the ground? So let's go ahead and draw ourselves some ground. Where's my green? Ground is usually green. There's my ground. I'm going to draw a building. It's a brick building, so it's going to be red. And I'm going to draw a ladder leaning against this building. So my ladder is a ladder, so that's usually steel, so I'm going to go with black. So here is my ladder. Now, it's a safe assumption that buildings are built straight up and down unless they're talking about the Leaning Tower of Pisa or unless they're telling you that the building's not straight up and down. Now, we do know some measurements. We know that the length of the ladder is 5 meters. And we also know that the wall and the foot of the ladder are 2.5 meters apart. So we know how to set this up, right? I mean, this is a simple trig question. You are looking for the angle formed between the ladder and the ground. That's this angle here. So we would let theta represent the angle. And then we go ahead and pick an appropriate ratio. Since we have the adjacent and the hypotenuse, it makes sense to pick cosine. So that means the cosine of theta is going to be equal to 2.5, the adjacent, over 5. And now this is the point where you pull out your calculator, where you'd say, okay, well, this is theta is equal to cosine inverse of, well, 2.5 over 5 is the same as 1 over 2. And this is where we are now expected to do this without a calculator. And perhaps this gets a little bit trickier. The reason why it might get a little bit trickier is because of the fact that, well, we either have to have a bunch of things memorized or we have to do our drawing backwards. Instead of drawing an angle, now we have to draw from arms or hypotenuses of a triangle. So if I want to find this angle, that means I have to find the angle whose cosine is 1 over 2. Well, this tells me that this has to be my adjacent, and this has to be my hypotenuse. So I'm going to go ahead and draw such an angle. First off, I'll draw my unit circle. You're used to seeing that now. Now my adjacent is 1, so I'll draw that length out to there. That's my adjacent, 1. And my hypotenuse is 2. So it looks like if I kind of sketch up, well, that would be kind of a distance of 1, 1, so I'll sketch up a little bit further. That's a good estimate of 2. So that's 2, and that's 1. And the angle theta we're looking for is this angle here. Now, fortunately, this is one of our special triangles. This is our 1, 2, root 3 special triangle. And a good way to remember what angle is what is across from the root 3 is the angle pi by 3. Across from the 2 is the angle pi by 2. And across from the 1, conveniently, is the angle pi by 6. So if we're looking for what angle theta is, then we could say that theta is equal to pi by 3. Now there's other answers, because 2 pi by 3 is also a legitimate answer. But that's not measuring this angle, that's measuring this angle. And I hope you found this video kind of useful. The key takeaway here is being able to find the cosine inverse or the inverses, so solving for an angle given measurements. And when you're given these measurements, when you're told that a sine equals a half or a cosine equals a half or a tangent equals root 3 over 1, you draw the actual arms of the triangle. Now if it has a sine, sine gn, then that could mean that your triangle might have to be drawn in one of these other quadrants. If it's positive, it's best to stick in the first quadrant.